Hey everybody, welcome back. Today we're going to be examining another speaker that a customer sent in, another one from Emotiva. And this is, I think, the third Emotiva model that's come through. The first two models that came in were the B1 and the T1 Tower. And both of those had a few issues that we had to address, and we went in and we designed some new crossovers for those. This one fared a little bit better. Let's dive into it and take a look at it. First of all, this model, the XB2, so I guess the next variation or generation of this model. Let's start with taking a look at the cabinet, which is fairly well made. The front baffle's fairly thick, probably an inch thick. The rest is 3/4 inch material, and there is a brace running through it here all the way through. So not your typical hollow box. Sure, there may be a little resonance left that you could line this thing with some no resin, tighten things up a little bit, but all in all, not too bad. Now it's got this recycled material that's kind of a feltish material that they're lining the whole inside of it with, plus a little polyfill that's thrown in there to cover some of it. They did not radius the backside of the driver through hole, and from the measurements that we took on it, that usually pops up 800 to 1,000. It usually creates a little wiggle, and I do see that little wiggle in the response, a little something going on. So, first little tip for free, take you a little die grinder and just go around the inside of this and knock this edge off and smooth it off and make it a rounded edge. And it may take away a little bit of brightness there and smooth the response out just a little. Ported out the back and tuned to about 50 hertz, pretty good for a little speaker. Big binding post cup on the back where all the goodies are mounted. So, just a black textured paint. It's inexpensive to make. Working on this thing, a little bit of a pain to get the drivers out. Let's start with the woofer. The woofer's a stamped steel frame. I'm not a big fan of that. If you do order a sheet of no-res with this upgrade, I would be sure and take some of the scrap pieces, pull the foam off of it and just use the damper and just run some strips down this frame and damp the frame would definitely help. They have a bucking magnet on there for shielding. I don't know why anybody shields speakers anymore. If you've got an old computer monitor or an older television that you're going to set this right next to, it would help, but those chances have gone to almost nothing since they've come out with these flat screen monitors and things like that. So, but it is a shielded woofer. The material that it's made out of, hard to really say what this stuff really, I mean, it has that carbon fiber look, but what it really is, who knows. But I do feel like this is fairly well damped, and there's not any ringing in it that I could see in the actual measured response. The tweeter is an air motion transformer type tweeter, and it has a fancy little cover over it that is held on magnetically. So you have to pull this thing off of it to get the tweeter out, and to get the woofer out, you've got to pop this little beauty ring off, which snaps in. But they also put some gummy goo on the backside of this thing, which made it really tough to get off. So you're going to have to be patient with this and go all around the inside of it and pull up on it and hold up on it and go all the way around and get this thing to pop off. And then there was some of that goo around the woofer just a little bit, just making it tough to get out. Same with the tweeter. It's got some of that gooey stuff all around it. And if you get the woofer out first, then you may be able to reach into the back of the tweeter and help push it out and get it to come out. Once you get the drivers out, everything else is pretty easy to work on. And this tweeter, they're typically pretty good sounding tweeters. The problem usually with this type of tweeter is they don't go down very low, and they often have a little bit of a knee in the response because they don't put anything on the backside of the diaphragm other than just another steel plate. Whereas some companies, there's one company I know of that'll put a deep back cup on this thing that they add damping material to, and it creates a more natural roll off, and it has a smoother sound. This one doesn't, and like I said, typically the problem is they don't play down very low. Surprisingly, this one actually did, and it crossed about 2300 hertz, so this one actually went down fairly low. So that was good. parts-wise, oof, man. I didn't look this one up to see what it sells for, but I know it doesn't sell for very much. But man, cheapest parts money can buy are the parts that are used on this thing. Electrolytic capacitors on the woofer circuit and then a notch filter on the woofer circuit. There's a couple of polycaps that may be on the tweeter circuit and one little air core inductor. Resistors are sandcast resistors, and yeah, a lot of these have steel ends on them on the resistors, and of course the iron core inductors on here, and the binding posts, which look pretty on the outside, but on the inside, steel nuts holding it down. So the whole signal is surrounded by something that's going to hold a residual charge when electricity passes through it. Not the wisest of ideas there. And so, again, they put the pretty on the outside and not on the inside. So let's dive into this a little deeper, and let's see how it measured. Because like I said, the first two Emotiva models that came in, we had to address issues. One, I think, in the tower was a significant ringing issue. And I don't remember what it was in the smaller one. I think there was some resonant issues and a choppy response. This one, not so much. Much better engineered than any of the other models that we've had through here. Let's take a look at it and see how this thing turned out. Let's look at the on-axis frequency response. Pretty smooth. We've got that one little peak there around 800 hertz. Maybe, I think that's more actually around 600 to 700 hertz, and a dip that's following it. That may be caused by this sharp edge. Anytime you've got a sharp edge on the inside of the woofer through hole, that sound diffracts off of that edge, and it does cause a problem in the response. So anytime you can, if you can get that edge rounded and smoothed over, then you minimize that diffraction, and almost always results in a smoother response, unless it's just a pure woofer only that isn't playing up very high. A couple of 100 hertz and below, it's not going to have any effect. But when you get up into that range, around 600 hertz to 1,000 hertz, those are areas where that sharp edge will cause some diffraction. Same goes with up there in the tweeter range. Some of the sharper edges here may be causing a little bit of those peaks going on. That may draw a little attention to itself as far as, you know, the way the sound is reflecting off of this versus if it were rounded. But overall, looking at this frequency response, it looks good. It really does. It looks good compared to all the other stuff that we've seen from this company and stuff from other companies. This has a nice smooth response. 10 degrees off axis, it smooths out even more. It looks better 10 degrees off axis. We'll throw that up there and let you take a look at that. Since there were individual binding posts on this, we were able to shoot the woofer and the tweeter independently, and you can see the roll-off of each of them is really smooth. We're not seeing any roughness there. Just a little bit of a peaked area there in the tweeter's response and a little down on the woofer's response. But as far as amplitude goes, not a problem. Now let's look at the spectral decay of that response and see if any of those peaks are only amplitude peaks, or do they have stored energy? Are they ringing? So let's take a look at it. And the whole thing looks really clean. That one little peak in the woofer's response back there around 600 to 700 hertz has a little bit of stored energy there, but not much. Again, if you knock this edge off on the through hole, maybe add a little more insulation on the inside to damp it, some of that might go away. So overall, what I'm seeing here with these first round of measurements looks pretty good. Now, let's look at the horizontal off-axis response, and as we do that, we see that it drops off fairly cleanly. We see a little bit of drop off back in the woofer's response between the woofer and the tweeter, where the tweeter really isn't playing down low enough to pick that up. A little bit of a dipped area there, but overall, not bad. And then looking at the vertical off-axis, that's starting on tweeter axis and moving up 4 inches per measurement. What we're really looking at is how well do they stay in phase over a wide range. We can see a little bit of a dipped area starting there at the crossover region, but it's not bad. I mean, compared to a lot of other things that come through here, not bad at all. Part of it is the acoustic centers, and the spacing from center to center is not that far apart. And the other thing is that tweeter was allowed to play down a little lower than what we normally see a tweeter like this. We're seeing it playing down to a crossover point about 2300 hertz. That helps it also because the lower it plays, the longer the wavelengths are at the crossover point. And then when you start moving up or down, the amount of phase rotation for that same movement is less because the wavelengths are longer. When you're crossing higher in frequency and those wavelengths start getting shorter, then as you move up or down and you're changing the time arrival of one versus the other, it's creating a much greater amount of phase rotation, and they tend to become out of phase more easily and cause big holes in the response. In this case, they did a pretty good job. Looking at the impedance curve. The impedance curve shows that we've got a 50 hertz tuning of the port, and right there at the tuning it drops to 4.6 ohms, and at the lowest point there, right there in the woofer's range, it drops to 3.9 ohms. No issue for most common receivers and amplifiers. If you're using it for home theater, though, keep in mind when you gang up a lot of 4 ohm speakers on a lot of receivers, they're not going to like it. In fact, a lot of the receivers still are rated at 8 ohms all channels driven or 8 to 6 ohms all channels driven, but they'll allow a rating of a 4 ohm speaker if it's just the left and right mains. So keep in mind if you're using it for home theater that it may be an issue. I don't know why Emotiva would create a little speaker like this and not make it an 8 ohm speaker. Obviously, it's going to be used in home theater quite a bit, but they didn't. And so overall, the measured responses on this one looked pretty good. Hobbs took the measurements when they came in, and I looked at it with him, and I thought, it doesn't really make any sense to go in and redesign something for this speaker because what they designed worked great. They just built it to a price point, and they built it to a budget price point. And that's one of the reasons this was sent in. It was just to see what can we do with it? Like, how much further can we take it? Is it a good candidate for some upgrades that might turn into a really good speaker? Keep in mind, people send us these for all different reasons. Most of the time when speakers come in, the customers have some kind of issue with them. They hear something they don't like. They want it to sound better. It's just not what they expected. Normally we get in speakers that have issues. Sometimes we get in speakers, though, that are designed really well. They don't have any issues. They're just built to a price point, and that is the situation here. It's just built to a price point. So what we did was we went in and we mapped out the crossover. We've drawn a diagram of the whole thing, and we're going to throw this up there on our site where you can order this as a kit with much higher quality parts than what this thing came with. Good quality air core inductors from US Cools, some JB Poly caps. We may throw in a few options, but I think we'll probably stick with JB Poly caps. Might do a Sonic cap option on the tweeter. We'll check and see how much that comes to and if it makes sense. All new wiring. Getting rid of this stuff. This is PVC jacketed wiring with push-on connectors that are made of tin. That's awful. That's eating up signal quality. So we'll get all that out of the signal path. We'll replace one set of these with a set of tube connectors, and we recommend when you're wiring the new crossover, wire all of it to one set of tube connectors, and we'll get all this out of the path. That'll improve signal transfer and clarity by quite a bit. We'll throw in some no-res. We may do the no-res as an option on this one because it's not too bad. And we're going to try to keep it as budget level of a upgrade as possible because it's a budget level speaker. So we want to kind of keep it in the same ballpark as what it costs. We don't want a $100 speaker with a $1,000 upgrade. It doesn't make any sense. I know this isn't a $100 speaker, but you guys understand what I'm talking about. We'll try to put something that's relative to the price point of the speaker, but it's going to give this thing a lot better performance than what it had. So all that's going to go up on the website. We'll get prices and all that there, so you can visit the site. It should be up before this video launches, and you can check all of this out and see what it costs and just click and order. Simple as that. All these parts should easily fit on a little piece of MDF that you can slide right through the woofer hole and mount in the floor of the cabinet. I know the brace goes right down the middle of it. It's going to make it a little tricky. You might want to mount the tweeter network on one little board and the woofer network on another little board and space it out, because you got to split that brace that goes right down the middle and it goes across the floor. Other than that, I mean, it should be an easy one to work on. The parts are not too involved. That's not a whole lot of parts, and it should all neatly fit in the floor of the cabinet. So that's it for this one. If you guys have any questions, throw them in the comments section, and we'll see you guys in the next video.